Hi guys, so I'm here to show you another example of what you can do with TensorFlow again, part of the series where I'd like you to know what's happening under the bonnet. You have learned a lot, so it's time to sort of have a better understanding of what's going on behind the scene. So this time, the previous video I showed you how to do a regression model. So this time I'm going to show you how to make a neural network, a very basic one, but then again under the bonnet, yeah? So let's call it neural net regression example, okay? With class. Okay, that sounds cool. So I'm going to import TensorFlow as TF, and I will from TensorFlow dot keras dot keras import. What do I need to import? We're going to be making neural network regression example, so we need the layers, yeah, because we will be making layers for regression. So first I import these two main libraries. Okay, so we're going to have object-oriented sort of class-based, method of doing this. So let's make a class, and we call this class neural linear regression. I know it's a long, ugly name, but yeah, why not? Neural linear regression. Okay. And where is this? What is this going to inherit stuff from? From TensorFlow.keras.model. Okay, cool. And that's the class. Then we're going to do define in it. Of course, self. Okay. Now what do I need to do? Because we're doing this inheritance thing, we're gonna call super. So super LSPU programmer. Okay, super init. Yep. Okay, so now what are we going to do? Okay, we're going to allocate, okay, two items, yeah, which are going to be associated to the deep layers, to the neural layers that we're going to be adding. So I'm going to say self dot dense one, yeah, so we got dense one equals layers dot dense, okay, layers dot dense. Let's put units equals 64 neurons here. Input shape, okay, previously we just worked with a vector, right? So input shape is going to be just one dimensional. Input shape is going to be just one dimensional, sorry. And activation equals let's say ReLU, of course. Okay, so that's ReLU, and then let's just go like this for the moment, and I'll show you something. Then self dot dense 2, okay, so I'm making the second layer, equals layers dot dense. Now it's a regression, right? And I want one predictor, so it's going to be really the output. So I'm going to say units equals what? 1. Okay. And input shape, we don't need to do that. And activation equals what? Do you think I should put ReLU, sigmoid? No, of course not. We're not going to have any activation because it's a regression. And yeah, as I said, let's just leave it to this. Okay. So what do we do when we are doing object-oriented sort of method of calling TensorFlow sort of function and inheriting from them? So we're going to now define the call. Define call, okay? And this call is going to be associated with self. And what is it going to take in? An X, an input, call it, yeah, whatever. Okay, now this is, I want you to pay very careful attention, yeah? So when we take this X, what do we want this X? What do we want to happen to this X, yeah? So we are giving a vector of numbers, like a number basically is going to go into this function. What do we want with this to happen? What do you want to happen with it? Yeah. So we want it to go and be fed into a dense layer. Okay. Which dense layer? We got two layers. Yeah. So would you agree that if I say answer, yeah, would that be so? Answer equals self dot self dot what? Dense one. Okay. And what do we feed into it? We're going to feed X into it. Okay. So if we do this, there's a 64 units out there. Okay. Uh, you feed this number to this neural network, some random weights are multiplied by it, then we're going to have 64 outputs. But we want one output, right? And we have it ready here, or output dense layer. So then we say, second answer, do you like to call it? Second answer. Not a very good name, but we'll change it. Well, I just want you to follow the rule. Self dot dense. And what do we feed into it? We feed answer. Okay? Except that, so I just want to take a look at this so that you understand how the data is going to, this X that is taken here, how it's going to flow through these. Yeah, so it goes into that, we call it ans. Then it fed into that, and we call it now second ans. But the right way of doing it is just, we're going to say X. Okay, because remember, X is going to get updated. Okay, every round. Okay, what is that? Okie doke. Yeah, that's about it. Except one thing is left. Um, in fact, why don't we say, sorry, dense two. Oh my God, yeah, dense two. X is also. You want to put this? Let's just call it final. How about that? Yeah. Then return final. Okay. This is better, maybe, to less confuse you at the moment. Okay, now we have this, all right? Let's just do it. So now that we have this class created, let's make an instance of it. So I'm going to say my model equals neural. Is this sounding similar? You have done this before, when I was giving you the lectures and you were making instance of functions before, So now we have created it ourselves. So model equals neural linear regression. So I just made an instance of this model. Oops, daisy, what did I do wrong? To be dense. What did I do wrong? Just bear with me. Have I done this correctly? What did I do wrong? Ah, God. It's me, sorry. Dense, misspelling. Okay. So, again, I just made an instance of this data, yeah? So shall we make our example data x train? We're going to use similar simple data equals Xtrain, what did I put this before? Let me just look at some. Oh yeah, np.array of what numbers going from 1, 2, 3, 4, 5, 6, and what d type equals np.float32. Is that right? I think so. Yeah. And ytrain equals np.array was 3 times, wasn't it? 3, 6, 9, 12, 15, 18, and d type equals np.float32. Yeah, okay, so that's our data. And again, forgot to import numpy. np add on me. Okay, so now it should be fine. So that error was because I just didn't import numpy. I forgot. You know, I forget things. Okay, so that's our data. But hold on a minute. Let's look at it. Xtrain dot shape. Cool. All right. Xtrain dot shape is that. Yeah. Shall we go and do it? So let's use the compile method. Yeah. So let's use the compile method. So I'm going to say model dot compile. So I'm going to compile the model, and I'm going to use optimizer equals SGD. Loss is going to be MSC. What else? Metrics is going to be MA, mean absolute error. Except that needs to be in the list. I think, isn't it? I keep forgetting this stuff. Yeah, I think that's alright. So shall we compile it? Yeah, no error. Good. So shall we fit it? Yeah. So model dot fit what? Xtrain and ytrain. Epochs equals 10. Shall we do that? Yeah. Model dot fit Xtrain, ytrain. Yeah. Oh, oopsie daisy. What happened? Blah blah blah. So you come and take a look, and it's here, and you read at the end regression full shape review none. Okay, remember when I did this, I said xtrain.shape, right? What do you think is happening? Okay, look at the shape and look at the input shape we have. Yeah, so what if I say xtrain equals xtrain dot reshape 1 6, yeah, and ytrain equals xtrain. Oh my god, xtrain equals xtrain dot reshape, and then ytrain equals ytrain dot reshape 1 6. Do you think this will resolve the problem? No. Let's try. Okay, so now xtrain dot shape. All right, so model gets compiled and then run it. Cool. Okay. Do you realize what's happening, guys? I want you to definitely pay attention to what this all was about, yeah? So this was just a single array, but remember with TensorFlow, you need proper shapes in there, okay? It's always important for a silly shape, you know, but you may sort of have your model giving you error and giving you a headache. What's the MA? Obviously, that's let's just put verbose equals 0. Yeah. Uh, so technically, I just think run it for 20 epochs, isn't it? So just fit it into it. So let's see if I say model dot predict xtrain. Yeah. As I said, I'm not bothered about anything, but rather I just want you guys to understand what's happening under the bonnet. Yeah. Model Moodle. Moodle. Okay. Model.predict xtrain. What am I getting out? A single number. Yeah. But xtrain. Let's look at xtrain. Why did we get a single number out? Think about it. Okay. So let's check everything right from beginning. Class. Edit. Clear all outputs. Okay. So we are taking that shape. Okay. Model equals neural regression. An instance of this model. Import numpy. This time we're going to look after our shapes, and these are matching. Yeah, 1, 3, 2, 6, 3, 9, 4, 12, 5, 15, 6, 18. Yeah, and this is the important bit. So at the moment, for xtrain dot shape, or xtrain dot shape is 6. What we're gonna, let me just do this again, and then I'm going to, so xtrain, just look, xtrain dot shape is that. I'm going to reshape it. So now xtrain dot shape is 6, 1, yeah. So it's going to be matching to the sort of shape that we're going to be feeding into this, yeah. And xtrain dot reshape, yeah, I've done that. Xtrain shape. Oh, I've done twice here. So now I'm going to compile the model, and I'm going to fit it on the xtrain with ytrain. It's fitted, so I put variable 0 so that we don't get all that things. Xtrain, this is our xtrain, right? That we are going to. So we're going to say model.predict. Let's do ytrain as well, isn't it? Ytrain. So ideally, we want these sort of values, these to be coming out. Yeah, so let's see. Okay, well, it seems our model is getting something right. Yeah, so what if I was to train it with 20 epochs? Do we get a better chance? Okay. How about, I don't know, 40 epochs? Yeah. So as our model is training, basically it's getting more and more close to what the target values are going to be. Okay. But as I said, that's not, I mean, like, what do we want to predict from this? It's like we can see the relationship between. But the idea was so that you understand how these models are basically working under the bonnet. Yeah. Now you might be like, Ali, why did you use compile and .fit? Well, usually you would be using these, yeah. Usually this is the method which you will use to sort of fit these, but on the previous section I taught you how to do it with gradient tape. So maybe we can go and just implement that here, just as a refresher. So if we were to do that, remember we need to define our optimizer. So optimizer equals TensorFlow dot keras dot optimizers. dot, what did I use? Did I use Adam or SGD here? Oh my God, I can't even remember. Where was it? SGD, okay. Dot Adam? Yeah, let's use Adam this time. So optimizer equals TensorFlow.crash.optimizer.Adam. Fine. And all right. So we have our optimizer. Now, instead of doing that fit, we need to basically run a for loop, defining our own epochs. For epoch in range, how many epochs we on? 40? Yeah. For epoch in range, and what do we do? With TensorFlow dot gradient, no, gradient tape as tape. Have you noticed the mistake I made? The mistake I made? Yeah. With TensorFlow, remember, don't forget this. As tape, I do it so many times. As tape, preds equals predictions, basically. Model dot model dot what? No, what am I saying? Model nothing. Sorry. Model, yeah. Just feed the stuff to the model. Model nothing. In terms of X trained, yeah. No model dot fit, yeah. Or model dot predict or anything like that. Okay. Preds equals model X trained, and loss obviously it's regression, so it's MSC is TensorFlow dot reduce mean of what? The square of errors, isn't it? TensorFlow dot square. What's the error? The error is preds minus X train. Yeah? No, Y train. Guys, preds, we feed it X train, it gives us some hypothetical predictive Y's. So preds minus Y is going to be your error or loss. Yeah. Don't put my X train here. You know why. All right. And now gradient. The tape is going to calculate that for us, isn't it? Gradient equals tape. This beautiful tape is going to measure tape dot gradient. Gradient. How is it going to calculate the gradient? It's going to create the gradient by loss, and with respect to model dot trainable variable. Trainable variable. Oh yeah, let's explore that later. Actually, that's going to be quite cool. And then optimizer dot apply, isn't it? Optimizer dot apply. So we applying the optimizer apply gradient. Yeah, we call the apply gradient method. Okay, and we apply to what? We apply to zipped gradients and model trainable variable. So trainable variable. Yeah, more than everything right. Let's just go from beginning just to be sure. So I'm gonna edit, clear all outputs. So I'm making my class based on TensorFlow, inherited from TensorFlow class.models. I'm making an instance of my model. Why did I keep importing NumPy? Anyway, xtrain is that. We know that the shape is not right, so we reshape it to be fit for what we have defined here. So we did the reshape as well. So extreme that shape. That's a correct shape. Now we're not going to do this, okay? We're not going to bother doing that because now we're using gradient tape. So we just keep this in hiding, X train, X test. Yeah, fine. And at the moment, we can keep this hidden because we haven't done anything yet. So we define our optimizer, TensorFlow that optimize the atom this time we're using. Then we define our number of epochs. So for epochs in range 40, technically, guys, you can put for I in range, yeah? For I in range, this thing, yeah? But we just put epoch so that it sounds more cool. For epoch in range 40, with TensorFlow.gradient tape as tape, pred equals model xtrain, loss equals TensorFlow.reduce mean. This is our loss function. Now gradient, we get the gradients by using tape.gradient, where we apply the loss and the model.trainable variables. At optimizer.apply gradients is zipping these gradient with the model, yeah, dot trainable. So here we are calculating gradients, and here updating weights based on the calculated gradients. Okay, very important. Now, before I go forward, before I just train this, or maybe I should show it up here. This modeled, what is model.trainable? Shall we see? Model.trainable, what are they? Trainable variable. Okay. Are we not getting anything there? Model.trainable variables? Yeah. Think about it. I want you to pause the video, yeah, and have a think. Or model.trainable variables. So let's run our model. Okay, so I just ran this. Okay, now we should have some trainable variables. Okay, let's look at it. Ooh, what's happening? Let's take a look. All these data coming out. Yeah, yeah. Do you realize what's going on? Yeah, set of trainable variables. Well, these are basically, these are all the weights in those 64 clear output, yeah. So, like in our model, we have 64 units, yeah. These are the weights associated with those 64 neurons. That's all it is, basically, okay. All right, now we have run our, this is like we fitted the model. So now I'm going to just say model.predict, yeah. There we go. Is that a good prediction? Not really that great, is it? So shall we run it for more epochs? Is it going to be better? Okay, changed a bit. Another 40 epochs. Let's take a look. Oh, things are changing. See, with every epoch, 40 epochs in this case, we are getting somewhere. So it took a bit longer, didn't it, to get there. Now, obviously, we can change these, yeah. Like you can change the learning rate and all that to see how this whole thing basically would be happening. These updates would get in slower or faster. But I mean, that's the whole idea, except that is there anything else I can show you? Let me think. Oh yeah. Oh yeah. Where is it? Here. Usually you will see, let me just adjust, let me copy this from some. You can usually do this as well. If I put comma here, and I put comma. You can also use this. I'd like you to read about it yourself. As you see, like I run it without doing this, but you can actually have kernel initialization sort of models. This is when you get more sophisticated, and you want to sort of run different models, having your kernels initialized differently and all this, yeah. Uh, Read about these, yeah. I mean, this is not necessarily, I really want you to actually understand this, but you can add other parameters here if you're interested. So if I do this, and if we just go as we went, yeah, so doing all the reshaping and blah blah blah, everything is fine. Optimizer model.trainable variables, at the moment it's not trained or anything. So we're gonna say for epochs in range that. So let's just put 100. No, let's just put 40. And model.predict, obviously it needs significantly more training, and we saw that. So we're just gonna put 140. Okay. So now if I say model.trainable variables, you saw that you get trainable weights, basically trainable variables, right? And this is, I would say, almost getting there, but obviously you need to do it further and further. So let's just say, let's say this is the model that you want, okay? I mean, we've done this before, but this is just a final reminder. Okay, great. What do we do? Yeah, we can always do, if you want to save this and basically use it later. Let me show you some stuff. So model, how many dense layers do we have? 2, right? So model dot dense 1, okay? Dense 1 dot get weights, isn't it? Get weights, hopefully. WEIGH weights. So these are the weights with these are the updated weights, guys. And these are the trained weights of for the first 64 sort of neurons. Yeah, these are the weights associated with that, and weights and biases, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5. Yeah. So 5 times, let me just 5 times 10. So yeah, so 64. Okay. Those are the weights, those are the biases, yeah. And what about our dense 2, guys? Dense 2, well, how many neurons was it? Just 1 neuron, yeah? So what are we going to get as weights for this? Dense 2, yeah, already done it. Neuron object, dense 2. I have spelled it right, haven't I? Hopefully. Dense 2. Oh, Disney 2. Oh my god, I really should. Okay, I'm not gonna change it at the moment, but because I just want to run everything all the way again. Disney 2. That's my bad spelling. Disney 2 dot get weights. Okay. So these are the weights associated with last neuron. You might be like Ali, but it's just 1 neuron. Yeah. So why is there so many? Like that shape? Oh, list object doesn't have anything, sorry. Oh, this is an array, isn't it? Oh yeah, it's a list of it. Okay. Let me so if I do len, I should get 1, yeah? Do you agree? len is 2, sorry, and then okay, so okay, so that's now the array. And if I do that shape, yeah, 64. So you might be like telling me why are there 64? But think about it, there are 64 neurons from the first layer that are feeding into this output layer. So all those connections are going to be having their own weight, okay? So let me see if I can, maybe I can do it like this, yeah? So this is what's happening, yeah? Oh my God, how am I gonna fit 64 here? I can't, yeah? You have to just trust me. So if there is 64 of these here, 64 of these neurons here, they're going to be having their connections, isn't it? Blah, 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 64, yeah? 1, 2, 3, 4, 5, 6, 64. So these are the weights, okay? That's what you're seeing as the weights associated with the style food. I don't know what that is, to be honest, yeah? Let's just stick to what we know. So 64 weights, basically, yeah? Now, to save a model, okay, we now know to save a model, what do you need to do? You can either save the weights, okay, or you can save the model. So if you wanted to save this model as a whole, this will be model dot save or cool model or cool model dot h5. I'm not going to run it actually, yeah. So that's one way of saving it. Or you can save the weights, yeah? Or you can say model dot save weights. Where is it? Save weights. Model dot save weights. And you save it as, I don't know, my weights dot h5. Okay. So you can do either of these methods basically. Well, they make a difference, of course, yeah. In case you go with save weights, yeah, later on when you load the model, okay, you can sort of like you make a similar model, then you can say model dot load weights, model dot load weights, yeah. Well, of course you need to import load model, yeah, load weights, model dot load weights, and you give whatever name you have saved the weights as. Or you will do model dot load model basically. But make sure you import load model from TensorFlow keras.model. Just should write it here for you. From TensorFlow dot keras dot models import load model. What does it do? Ah, TensorFlow. Yeah, and you can also do that. Right? Well, I hope you have enjoyed this, and yeah, make sure you practice with this, just play about so that you get the idea in your head, you know, what this is all about. I hope this has given you a better insight into, you know, how all these models and all these stuff are working under the bonnet. Take care, guys.